Hello and welcome to this video on soil compaction equipment and production estimation. In this video we'll cover the shown three learning objectives. We will learn about the different compaction energy application and their corresponding compaction equipment. We will match the best compaction energy and equipment to the different soil types. And finally we'll see how to estimate the production of a compactor. In the previous lesson, we learned about the compaction specifications and how the compaction quality is tied to the soil dry density and moisture content. We learned about the compaction curves that are developed by the standard Proctor tests. We learned about the compaction behavior of the different soil types and how to test the compaction quality on site. And we acknowledged the importance of water in soil compaction operations by discussing the different water content control approaches and the water application quantity calculations. To compact the soil and squeeze the air voids inside, there are four main ways of forms of energy to mechanically compress the soil. We can either apply a simple static pressure, pressure weight, vibrate or shake the soil, hit the soil with an impact load, or knead and manipulate the soil. From the previous lesson, we can see that the Proctor test in the lab uses the impact energy to compact the soil sample. On site, however, we need to match the compaction equipment with the right energy form to efficiently compact the right soil type. There are many different compaction equipment used for general and specialized purposes. We will cover here these 7 compactors and relate each one to one or more of the 4 compaction energy methods. Damping foot compactors are high-speed, self-propelled, non-vibratory compactors. They usually have 4 padded steel wheels and are equipped with a dozer blade. The wheels are padded with tapered shanks that go inside the compacted soil lift. Damping foot compactors leave a fairly smooth sealed surface, so hauling units are able to maintain a high speed when traveling over the fill. Also, since dozer-equipped damping compactors do both spreading and compacting, the contractor may be able to reduce the number of spreading equipment on site. Damping foot compactors are best suited for large projects. They need long, uninterrupted passes to build up speed that generates high production. With the help of their padded wheels, the damping foot compactor knead the soil and squeeze the voids inside. This is why these compactors are suitable for fine-grained soils like clay and silt. The damping foot compacts the soil from the bottom of the left to its top. This is why the top of the soil is not adequately compacted, which measures about 2 to 4 inches for a typical 8-inch embankment. Another roller type should be used for the top 2 to 3 inch that the damping foot did not compact well. Like we'll see later, pneumatic and drum rollers can be helpful here. Sheep foot compactors derived their name from the fact that early Roman road builders would herd sheep back and forth over base material until the road was compacted. A sheep foot compactor and a damping foot compactor may look similar, but sheep foot compactor usually exists in the form of heavy drums and not wheels with long shanks. The drums are heavy that they can produce 200 to 1,000 pounds per square inch. We have some needing compaction action from the sheep foot roller, but compaction is mostly static due to the heavy drum weight the long shanks, and the fact that the drum axis is towed, not mechanically powered. Sheep foot compactors are effective in clayey soils. From their names, impactors are compactors that use dynamic shocks to compress the soil. These compactors use three-sided or four-sided or five-sided heavy-towed drums. The non-circular shape of these impact drums result in lifting the soil and impacting the soil at cycles that are dependent on the towing equipment speed. Impact drums are helpful for a wide range of soils, but they are more effective in fine-grained and well-graded soils. They can handle thick compaction lifts and help in reducing the required moisture content with their high impact energy. Pneumatic tired rollers apply kneading action to compact the soil by having the front and rear tires at different paths. The rear tires are spaced to track over the uncompacted surface left by the passage of the front tires. The wheels oscillate to follow the shape of the compacted soil and leave no spot uncompacted, which is a little advantage over the other compactors with steel wheels or drums. Pneumatic rollers are effective in compacting granular soils, especially granular base materials and asphalt pavements. They are more suited for small to mid-size soil compaction jobs, not large, thick lift embankment compaction jobs. Vibration creates impact forces which create greater compaction energy for the same static load. Vibratory rollers have vibrating drums in their front axle that are actuated by an eccentric shaft that produces the vibratory action. Just to give you a sense of it, the drum vibration can range from 1000 to 5000 per minute. Vibratory rollers are very effective in cohesionless granular soils like sand, gravel, and large shot rock. When these soils are vibrated, the particles shift their position and nestle more closely with adjacent particles to reduce the air voids and increase the density of the mass. As vibratory rollers are not that much heavy, they can handle thin to medium left thicknesses up to 9 inch. As an improvement to vibratory rollers, their drums can be padded with steel shanks to extend their effectiveness to soils with more than 50% cohesive material. A Tampic foot vibratory roller is effective in compacting most soils except for pure sand. It also can compact thicker soil lifts thanks to their ability to reach inside the lift with the padded shanks. But this roller requires long uninterrupted compaction passes so they can build up speed and achieve high production rates. Finally, double drum vibratory rollers are more common in compacting asphalt pavement surfaces, granular bases, and sub-bases. They deal with thinner lifts compared to single drum compactors. Let's now map the compaction energy application to the equipment suitability to specific soil types. Let's first see how the four main compaction methods, impact, pressure, vibration, and kneading, apply to the four main soil types: gravel, sand, silt, and clay. Impact is generally not the best compaction method, except for clay when it is well confined, like the Proctor test. Pressure is similar to impact in that it is more effective in cohesive soils. For granular cohesionless soils like gravel and sand, we a compaction method that we prefer a compaction method that allows the movement of the particles and adjusting them to fill in the voids. This leads us to the fact that vibration and kneading are the best compaction methods for gravel and sand soils. Now let's match the equipment to their designed compaction methods. This table summarizes the previous slides. You can see that all compactors apply at least pressure compaction with their weight, even if there are light equipment. Also, you can see that the vibrating pad foot is kind of super, where it combines all compaction methods in good degrees. This is why when we match the soil to the equipment, vibrating pad foot can be utilized in compacting all soil types. We see here this summary table that lists the vibrating pad foot for gravel, sand, silt, and clay. Pneumatic rollers are also effective except for the clay material. Smooth static rollers are effective in fine granular material like sand and pavement. Finally, tamping foot and sheep foot are effective in cohesive soil. Coarse soils enjoy the privilege of being compacted in thicker lifts with less passes, which means that compacting the same embankment of coarse fill will be much faster than compacting it if it is made from fine soil fill. Here are some suggested speed values for the different compactors. Except for pneumatic roller, you can see that most compactors are really slow. The compaction productivity is calculated using this simple formula. The production is calculated in compacted cubic yards per hour, and it is dependent on four variables: the width of the roller pass, the roller speed, the thickness of the lift, and the number of passes required to achieve the target density. The constant 16.3 needed is needed to match the units of the different variables, so make sure you are using the right measurements and units of the variables. Finally, let's see some cute compactors. Compactors don't have to be huge. Here are some small compactors that are helpful in small and tight fill activities. Thanks for watching this video on compaction methods, equipment, and production estimation. See you in other videos.